Okay, so let's just hide that. No, that's what I want to do. Okay, so this was fine. No problem there. You did all that correctly. I'll only go over the ones that we made a mistake. So first one here, it said it is bonded together by weak single covalent bonds. Well, it is true that it's single covalent bonds, but they're not weak. And also, these are not the bonds that we need to break when we boil them. When we boil a liquid, we're breaking intermolecular bonds, whereas covalent bonds are intramolecular bonds. So intramolecular bonds are the bonds within the molecule itself, and intermolecular bonds are the bonds between from one molecule to another. Those forces are weak. So if we have a look at what it says in the mark scheme, the intermolecular forces, as in the molecules the forces between adjacent molecules, are weak, and as a result, little energy is required to overcome these forces. So the structure of your answer was correct, apart from you're referring to the wrong types of bonds. You would still have to use this concept of energy. Little energy would be required, rather than just simply saying it's easily broken. Okay, so remember that when you boil them, the covalent bonds are these bonds that bond between the carbon and the fluorine atom, in this case, and we're not breaking those when we boil the substance. We're just separating this molecule from other molecules nearby. Okay, so that's that one. This one was fine. This one was you made a mistake here, but you missed a hydrogen there. That carbon only had 3 bonds on it, so you would have to put a hydrogen on there. Okay. This one we've got basically it's an alkane reacting with a. Is it an alkane? Yeah, it's an alkane reacting with a halogen, and what happens in this case is you'll get a halogen displacing one of the hydrogens. I don't know if that's the right word to use, but it replaces one of the hydrogens, and that hydrogen joins with the other atom within that halogen molecule. So you'll end up with this and this. Okay. So the halogen molecule breaks in half, and half of that joins with one of the hydrogen atoms, and the other half replaces the hydrogen atom from that. And it's called a substitution. The type of reaction is called a substitution. Over here, this is a miscalculation here. So what I'll do is I'll stop the video from the previous question, because this one's going to take a little bit longer to go through. So I'll just stop that and save it just before.